When I think of Dr. Martha Herbert, lots of things come to mind, but today we're going to talk about what is a giant. A giant is someone who does not set out to move history, but they do. They glorify in the beauty of life because they respect it and move it forward. They don't live in a cave. They don't live for themselves. They glorify the way all nature was meant to be. We are faced with autism. Autism is a disease, an aberration of the way things were meant to be. The health that children were meant to enjoy, the function that adults were meant to enjoy, the camaraderie that families were meant to share. Who will help us? With courage and foresight, Dr. Martha Herbert courageously shattered the dead paradigms of hopelessness and is leading the way in explaining why so many children are sick, why our future is imperiled, and how we must act if the next generations are to be saved. Dr. Martha Herbert, marrying medicine and philosophy, examines ethics and existence and has effected a major shift in the medical paradigm of autism. Autism is not hopeless. And with her medical training and experience at Harvard, Dr. Herbert shows us how we can help. Please help me in joining Dr. Martha Herbert to the podium.
Can I move this thing up? Great, and I can lean better. I want to thank everyone for coming on this rainy morning, getting up in the dark. It isn't this dark down in Boston yet at this time of the year in the morning, but we're getting there. And coming for this important process, and coming knowing that you're going to be sitting here listening to things, and some of them are going to be challenging to understand, but that it's all very important and it's part of the world historical moment we're at right now. Come up here.
I just got told this. So parking, you're allowed to park outside in the circle, but you have to have a tag on your dash. After 10:30, they're going to start ticketing. So for those of you that haven't done it, we have a break from 10 to 10:30. So please go out and put a ticket on your dash. Sorry, Martha, you get a $30 ticket otherwise.
No, that's
Spend
really
the
a big deal.
$7, okay?
No. This is, I'm a former New Yorker, and people who had cars devoted their whole lives to scheduling around parking in the street. So. Actually, where I live in a town right outside of Boston, and we, in the United States, the cities are returning to parking tickets for revenue because there isn't enough revenue. One time there was a snow emergency, and they towed $300,000 worth of cars, and it never snowed. And they insisted it was within their rights, but they had to give the money back. So in any case, back to business here. I want to talk about what I'm going to talk about, but before I do that, I want to talk about Ted Carr. One very important thing was completely left out of everybody's comments on Ted Carr, in that he was so hilarious. He was a stand-up comic. I had weekly phone calls with him, and he just was a scream all the time. He had this, and the emails that he would send at 2 in the morning were hilarious. We put together a compendium of him, and also, after he was killed, a compendium of segments of his lectures in various places. He had to get bleeped out at various points because he was a bit carried away. But I just want you to know that in addition to being a deeply motivated, caring, brilliant person, he was astonishingly, ironically funny. I've known him for a few years. I remember him giving a keynote talk at the Autism Society in the United States, and he gave an amazing discussion of the problems with how giving behavioral reinforcement for a child who has a meltdown can be misguided if you don't understand medical problems. The child has a meltdown. You're giving them M&Ms. You give them meltdown. So, okay, they have aggression. You give them Risperdal. So then that doesn't work, so then you escalate to another drug. It turns out that if the child has gastroesophageal reflux, first of all, M&Ms make it worse. And then he started talking about his own gastroesophageal reflux, which the point being that it was very personal to him that we find the right way of dealing with what the problems are, and the right way of dealing with aggression from gastroesophageal reflux is to clear up the reflux, not just to treat it with psych meds. So, and I just want to share again the grief which will not go away about Ted's passing. He had just been introduced. I introduced to some people at MIT Media Lab with whom we're working to develop miniature technologies to help monitor and predict behavior before it gets problematic. And when Ted was killed, Rosalind Picard, who's the head of the effective computing component there, said, you know, I can't believe this. I'm looking for some technicality so that it's just not true. It just did not compute. Let me move on to, and the other thing is I want to say that we connected. He was one of the founders of positive behavioral support and functional behavioral analysis. And I'm very involved in functional medicine. And I got him to go out and buy the functional medicine textbook, which underlies a lot of what I talked about. And he had a complete epiphany about how relevant this was and how it tied together. And when he died, we felt we'd been set back several years in the work that we have to do. So what I'm going to be talking about is really about function. And my title is Chronic Active Biological Processes in Autism, Secondary or Core Issues. We've been taught that autism is basically a hopeless genetically determined brain damage condition. And if you want a sentence summary of what I'm going to say is that we don't really have evidence for that. And there's actually a better way of thinking about it. So that's what my talk is going to be about. That's what Ted and I were planning to do a lot of writing about, and I'll just have to carry out without him. The overview is that we have a view of autism that is genetically determined and brain-based, and I'm going to explain to you its limitations. There's an emerging new model. It's about the whole body. It's about genes and environment, and I'm going to talk to you what that's about and where we're at with it, what's strong about it, and where we need to move to make it better, where we are still stuck, the features we need to develop, and how the community can generate data. I think the community needs to be part of the scientific process. So this is a little bit small type, but the classical model is of autism as a neurological disorder with specific parts of the brain that are impacted and specific brain systems deficits. What we've been discovering from scientific investigations and clinical experience, but particularly some path-breaking science, is the whole brain is involved. The whole brain is involved also as a physical organ. The tissue is involved, not just the way the circuits are laid down. What we were taught about autism is that it has these three behavioral domains: communication, social interaction, and repetitive behaviors. But if anybody with a child with autism will know that there's more to it than that. There's sleep, there's sensory, there's in many cases gastro, a lot of other things. And they may not be secondary. Just because we defined it as behavioral doesn't mean that it is behavioral at its core. It's just the thing that it's easiest for us to see. Genetically determined, well, I'll go into that in more detail, but we haven't found the gene. There are genes in children with autism that the parents don't have, gene variants. There are rising numbers of people with autism that haven't been fully explained away and that can't be explained by genetics. And there are immune and metabolic features of autism that suggest environmental involvement. Finally, the word static encephalopathy. Static means it doesn't change. Encephalopathy means a problem with your brain. That's what people think of with developmental disorders. That's the way they've been thinking about autism. Evidence is emerging that this is not a static encephalopathy. Technical term is dynamic. It moves, it changes, it's variable. And what we're seeing is transient and sometimes sustained loss of diagnosis. So overall, I have a paper on my website, which you can get to, marthaherbert.com, called Is Autism a Brain Disorder or a Disorder that Affects the Brain?, where I first laid out in detail a lot of the arguments that I'm laying out here, although I've pushed them further since. So there are a series of problems with that challenges that are posed by autism and how we deal with it that make it hard to use traditional research methods and traditional clinical forms of practice. The heterogeneity, maybe you've heard the expression, when you've seen one person with autism, you've seen one person with autism. So much difference person to person. Complexity. What I mean by that is it's not just behavior, it's not just brain, it's not just genetics, it's also metabolism, it's also immune, it's also mitochondrial, it's also a lot of things all at the same time. So that's complex. And the individuals vary from each other at all of those levels. That's really complex. Chronic. It's not just something that happens before birth and plays out like an inexorable plot that you can't do anything about, but there are chronic active processes, medical issues that are active, ongoing every day, and not just a product of the so-called autism. And finally, there are amazing areas of overlap between autism and many other complex modern chronic conditions. If you look at the metabolism findings, if you look at the immune findings, even some of the brain findings, they're very similar to things going on in other conditions. The metabolism and immune findings are similar to major chronic diseases that we're facing around the world today, which are on the upsurge, and many of us would argue strongly that this has something to do with the environment. So all of this is challenging for a scientific research tradition which looks for specific things to target specific diseases. It just doesn't look like that's the kind of thing it is. And the link I was telling you about that Ted Carr and I shared about functional medicine is a way of thinking about function that isn't tied to this narrow definitional approach, which is not holding up in 21st century systems medicine anyway. So functions of science. I'm going to be talking to you about various different aspects of science. We think of science as a source of truth, of discovering new things, of solving problems, of sleuthing down things that we need to figure out. I also want to argue that science is a source of rhetoric, a source of models that inform our thinking and that can also restrict our thinking. And I want to argue that the model we've been using in autism has been seriously restricting our thinking and getting in the way of our doing the help that we can do for the most possible people in the most ways and the soonest possible. And so what I think we need to do is change the model and reallocate resources so that we can help the most people in the most ways as soon as possible. I wrote a long paper. This is the title, Autism, the Centrality of Active Pathophysiology. So the active chronic processes I was just talking about, a shift from that static, unchanging encephalopathy to chronic dynamic encephalopathy. It's a long and technical paper. It's in press, and if you want to actually chase down the more detailed argument for what I'm saying, it's in this paper in a book that's coming out very shortly. I've already submitted the corrected proofs. There's a much shorter piece, a guest editorial, Learning from the Autism Catastrophe, Key Leverage Points. I'm calling it a catastrophe and not a tragedy because it isn't necessary. So much of this is not necessary. I'm not sure anyone can say whether it's all not necessary, but a lot of the suffering is really not necessary. So the classical model of autism goes, you've got a gene. See if I can do it like this. Okay, good. Theoretically, there's some kind of gene that affects some kind of brain region and affects the primary behavioral domain. Another one for social interaction, another one for communication, and when you get all three, you've got autism. So we've spent enormous numbers of millions of dollars hunting for the genes in the brain regions, and we haven't found them. So there's an old saying about the carpenter who says, you know, I cut this thing off 6 times and it's still too short. So where do we want to spend our money? Do we want to spend our money doing the things? I mean, there's a place for all of the kinds of research, but it needs to be in coordination with other pieces of the puzzle. It's not an either or, it's a both and. And this is my both and diagram, so I'm going to walk you through it because there's a lot going on in here. There are genes that seem to be different in many people with autism. Most of those genes don't have a very big effect, but there are differences that make you maybe a little more vulnerable. In most people, they don't look like big determining genes. Environment seems to need to step in for most people to be a second hit. Epigenetics means gene expression. That means that the genes themselves are the same, the actual gene sequences, but which ones are turned on and which ones are turned off are altered. The turning on and the turning on off process is affected. And this is an explosive area of research right now, not just in autism. In fact, autism is just starting to get on that bandwagon. These causative factors outside of this box, which is the person, alter your biology, not just in specific little regions of the brain that create the autism, but they alter the biology in the cells of your body all over the place. That's pervasive. And you see vaguely like these little circles interacting. The ways that are, the things that are altered are interacting with each other and reinforce each other. So it becomes this kind of thing that it's almost like quicksand. When you fall into it, it's hard to pull yourself out because something else keeps pulling you down. These biological, cellular, molecular differences affect your sensory and molecular signaling, and it affects your anatomy, and these things reinforce each other. We're coming into appreciating much more the huge impact of the sleep problems, the sensory motor problems, the fact that somebody with autism right now sitting under a fluorescent light might be very irritated by something which a typically developed person might not even notice. And that can affect the threshold that will aggravate other issues. Epilepsy, 9 to 50%, with a lot more having interictal abnormal electrical activity, which is just coming into discussion in mainstream medicine. All kinds of somatic issues, gut, GI, immune. What we see is the communication, social interaction, and behavior, the unaided eye of a social being. That's what you see. So we've been calling that the autism. But I think in a whole body systems or understanding of autism, we need to understand that the whole thing is the autism, the whole thing. And there aren't areas that are more primary than others. They're all together and they're all interactive. One thing I want to say, I think it's very important to remember that autism is often talked about as a disease or deficit. There are people who say, and I think with some good reason, that there are many, many strengths to people with autism, many gifts. The talk tomorrow with the Handle method, helping extraordinary people do ordinary things. We often see that when people improve or move toward recovery from autism, they don't turn into an ordinary person, they turn into an extraordinary person. And it's almost as if there's something about the vulnerability, the sensitivity of a brain that can do extraordinary things. It's almost as if that can get hit and be kicked into a maladaptive state, that the cells can be kicked, but then when you bring it back, there's an extraordinary quality. There are researchers here in Canada, Motron and his team, who are showing things, many things that people can do with autism that typically developing people have a harder time doing. So I think it's very important to remember that side of autism as well as the suffering and the challenges. I think that this whole body systems approach is on the map in ways it wasn't a few years ago. There's more peer-reviewed publications on body features. There's a lot more than there were a few years ago. There's more books on body and systemic features in autism. I'm going to mention some of them. A volume in 2008 edited by Andrew Zimmerman, the volume that's coming out now by Chauhan, C-H-A-U-H-A-N, a special issue of a journal, the initials are AJBB, on autism, which you can get free online on biological approaches to autism. There have been symposia on immune system and environment at the International Meeting for Autism Research, which you would never have expected more than 2 years ago. There have been funding announcements for people to do research on this. I still think that we have a long way to go, and that still the research community is trying to look at these new areas without developing research methods yet that account for the complexity and the heterogeneity and all of that. So you take a step forward, but it still falls back, and we have still a lot more work to do. Where are we stuck? Well, one of the areas that we're stuck, and I could one of these days I'll give a whole talk about, more talk about what that new method needs to be. a complexity-oriented method. But one of the places that we're stuck is that many of the arguments supporting the whole body approach are still based on inference. So we know that toxins affect many processes that are involved in autism, but we haven't shown that they affect autism directly. So we infer that because the processes are affected, they must be affected in autism. That's good for people who are sympathetic to this point of view, but not to skeptics. Treatment. There are various treatments that affect many processes abnormal in autism. We have evidence for them affecting processes, but not so much for the autism. So these are things that we need to work on. This is a slide by my colleague Mark Corrales showing that there's been the fatness of the arrows, or how much literature there is. This is a researcher whose job is at the Environmental Protection Agency in the States, who does computer analysis of how many articles there are in the literature about subjects relevant to autism and other things. So there's lots of articles showing links to toxins to cells, biomarkers, genes, brain regions, behaviors. Not that many, and there's linkages between all the things here in yellow and autism, but you don't connect the dots all the way. So people don't always get it. So again, like I said, there's a lot of work to do. Here's a quotation that was in a news article some months ago. It was about the peer-reviewed publication by Dan Rossignol supporting hyperbaric oxygen treatment. And what I'm arguing here is not pro or anti-hyperbaric oxygen treatment. It's about the level at which we're talking about it. So the reporter said, and this wasn't attributed to anyone, well, first I should say that one of the reasons that people argue hyperbaric oxygen treatment is important is that it treats the poor blood perfusion in the brain. Hypoperfusion, cerebral hypoperfusion. But cerebral hypoperfusion is actually not talked about that much in the literature, even though in my group, we found 19 papers in the peer-reviewed scientific literature using either PET scans or SPECT scans. And out of those 19, 17 documented low perfusion, 1 documented nothing, and 1 documented both low and high, more low and a little bit of high. So a huge amount of evidence supporting the existence of cerebral hypoperfusion, but most people don't talk about it. And even the people who wrote the papers were psychologists who didn't say, why is the brain doing that? They just talked about it as if it was just static, just there. The reporter said, nevertheless, cerebral hypoperfusion remains out of the mainstream of scientific thought on the source of autism, which is now focused on variant genes and environmental factors that combine to impair development in early childhood. So he's got the genes, he got the environment, that's good, but he's still acting like that part that isn't yet inside the person's own organism, that's what we need to be studying. So I'm asking on this slide, what's wrong with the statement? And the answer, from my point of view, is that it confuses cause with mechanism. What caused it, which is some sort of gene-environment epigenetic alteration, with what keeps it going on every day, going on in the person who's affected. And what I would call that is the physiology, or the pathophysiology, when it doesn't work right. So we've advanced from genes causing brain damage, which is the old model, to now we've got genes and environment causing brain damage. And the mainstream of scientific thought is not looking at the physiological mechanisms as mechanisms of something active being caused every day by things we might be able to address and treat. And I think the subject of the biomedical part of what people are talking about is that if you look at it that way, there's a lot you can do to help. So this is a diagram, and it is from an article I co-authored, and it's in the book that came out last year, edited by Andrew Zimmerman, Autism, Current Theories and Evidence. The model that I was taught when I came into this field in 1995 was that genes cause a static encephalopathy. So you've got the cause is genes, the mechanism is early developmental damage, and the impact is a fixed functional deficit. Forget it, nothing you can do. Lots of argument advanced things to a model gene-environment caused static encephalopathy. So you've got environment, and the impact is a fixed functional deficit. Forget it, nothing you can do. Lots of argument advanced things to a model gene-environment caused static encephalopathy. So you've got environment, caused static encephalopathy. So you've got it causes early developmental damage. You get a fixed functional deficit. So I think that gets us halfway to where we need to go. We've now advanced from being stuck at the first step, and now we're stuck at the second step. But you could see by all the empty space on that slide that there's more room. And there are 2 steps to go. Epigenetics, so it isn't necessarily genes or environment, it's the impact on the way the genes are expressed. You can get early developmental change. It can also be gene expression that can be reversed. Epigenetic alterations in gene expression can persist for several generations. They can also be reversed by some lifestyle modifications, and we're just beginning to learn about that. Diet, for example, is being shown to have a significant impact on gene expression. This is something that which is something that is probably related to what Laurie was talking about. Oh no, it was you, I'm sorry. About the cancer, people not taking seriously that diet could help. And now this is probably one of the ways in which it can. There's one last way where it's not only at the level of genes, it's environmental agents themselves altering metabolism, altering the chemical regulation of activity in the brain that leads to what I would call a chronic encephalopathy. Encephalo is brain, and pathy is a problem with it. But not necessarily a fixed one. It may be a stubborn one. It may be hard to figure out how to give it a break, and I'm going to get to that later. But it's not the same as brain damage. It's just not. If you have a chronic encephalopathy and you have some brain damage, the chronic encephalopathy will make the brain damage have a worse impact. But even if there is brain damage that you can't fix, you can do a lot about having the milieu of the person still facilitate optimal functioning. So those arrows are the impact of the encephalopathy on other functional issues. Now I'm getting to the core of my talk. I've laid the groundwork, and now what I'm going to do is talk about what are our assumptions that people have been bringing to thinking about autism. And this goes back to what Senator Munson said about the old ways of talking about developmental disorders where people who had children with developmental disorders lived in the shadows. And that's because of these assumptions and kind of a visceral, unexamined reaction to people who are different than us. Developmental disorder, clearly autism is a developmental disorder because it happens during development. But that's not what people mean when they say developmental disorder. They say they carry a lot more baggage with it, and here are some of the parts of it. They assume it's all genetic and predetermined, that the damage is done really early before you're born, that the brain is fundamentally and irretrievably differently structured and broken, that this damage is the cause of all the problems and that there is nothing you can do about it. Does that look familiar? I mean, many people have been told they have a diagnosis with autism, there's really nothing you can do. At some point, you'll have to put your child in an institution, get on with your lives. And that's based on the prognosis that rests on these assumptions. So what I'm going to say is, let's examine the evidence. Has anybody ever proved that these assumptions are a valid way of approaching autism? And you can imagine that I'm setting you up for the answer being no, so I can tell you that ahead of time. It's amazing when you think about it how much unquestioned assumptions can even work at the highest levels of science. So here's a quotation from a friend of mine. I had his name in here, but I took it out. But whatever. He said, well, I had a number of patients who had autistic features, but they didn't really have autism because they had Lyme and mold exposures. And does that make sense? Does the Lyme and the mold mean, oh, there wasn't autism? That would mean that, well, we know what autism is, that there is some sort of platonic essence or true or pure autism, and anytime we know an environmental factor, or for that matter, a genetic factor, it isn't really autism. I would argue that there is no platonic essence of autism, that autism is what your brain does when it is challenged in certain ways, And it doesn't matter whether it's from a gene or environment or infection or whatever. If that's what the brain is doing, that's what it's doing. And you should know that I don't think I have my slides in here that I often do. Autism is defined by these three behaviors: communication, social interaction, and repetitive behaviors. And I had that in the diagram with the gene-brain behavior. But what you need to know is that there's nothing about prognosis in that definition. There is nothing in the definition that says, forget it, it's never going to change, and if it does change later, it wasn't autism. That's not part of the definition. That comes from additional assumptions that people have overlaid on this condition, and I don't believe those are really evidence-based. So I'm going to go through those points one by one. Is it all genetic and predetermined? One of the reasons people say that it's genetic is that there are twin studies where the identical twins are more likely to both be autistic than the fraternal twins, and also because in families where there's a person with autism, subsequent children are much more likely to have autism, though by no means inevitable. So the identical twins both having autism, that's called concordance. And oftentimes people say that it's 90% concordance. Going by the earlier studies, the actual figure is 60% for full autism, that if one person has autism, the other person has full autism disorder. 60% for if one person has autism, the other person has features of autism. And that's a lot, but it's not 100%. In the fraternal twins with different genes, the concordance has ranged from 0 to 30 or more percent. And the higher the concordance in the twins with different genes, the more it points to shared environment rather than genes. But the jury is still out. Now, why isn't it 100%? There are certain genes that if you have them, like Huntington's disease, if you have a certain gene variant with a certain number of triplicate repeats, which is something that happens in the gene, you're going to get that disease at some point in your lifetime. Autism is not like that. What accounts for the incomplete concordance? Well, I want to bring up a Swedish study of identical twins, and I should say that this was of schizophrenia, not autism. I forgot to put that in the slide. They had a group of people who all had schizophrenia, and they were all twins, and they all had identical genes, identical twins. So how do you divide up a group like that? One group had the infants shared placentas when they were in utero, and the other group, they had separate placentas. In the group that looked like they had the same placenta from the markers, there was 60% concordance of autism. In the group that had different placentas but the same genes, it was 10.7% concordance. So that flies in the face of the assumption that concordance means nothing other than genes. The authors of the paper suggested this was about infection, that we've been overestimating heritability and that we should look at infection. I'm not prepared to say it's just infection, although I think that's a really important consideration. But in any case, it has to do with environment, in utero environment in some fashion. And that, if that's the case, then we really need to rethink where we're putting our resources and reallocate them. It's like you take your portfolio and you put it all in high-risk stock and you didn't get it, and now you got to change that diagram and reallocate it. All right, here we go. Look at that portfolio. If you think that 90% concordance means 90% heritability, and that only leaves 10% for genes, you are misinterpreting that data. And here's why. Genes can be necessary but not sufficient. Environment can be necessary but not sufficient. If you have the gene but the environmental second hit doesn't come along, the gene isn't going to matter. If you have the environment but the gene, the environment's not going to matter. That's the extreme cases. There are shades of gray in between in gene-environment interaction. But the point is that you can have a complete need for the gene and a complete need for the environment, and they're both 100%. The bottom line is this does not have to add up to 100%. It's more like some kind of a Venn diagram where both are necessary, and only in the extreme cases of genes or environment can either one be enough on its own. I wrote a paper some years ago, Autism and Environmental Genomics, to try and shake us out of the genes or environment thing and say that this is not an either or, it's a both and. These are figures from the state of California in the US that came out early this year. What you see is 1987 to 2007. Whoa, I'm going to do it looking this way. I can't do it the other way. 1,200% increase in autism, very little increase in epilepsy, mental retardation, or cerebral palsy. Now, many people argue that this isn't real because we weren't noticing these people before, they've always been here. So somehow 1,200%, or the 1 in 91 or 1 in 63 in the UK, or 1 in, what is it for the boys in the US, that they were already here, always here, but we never saw them. It's a little hard to believe that we never saw these people. It's true, I have another slide I didn't include for length, but I'll talk you through some of the points. It's definitely true. I know people who are adults who I now would say, look, this person's on the spectrum, that got diagnosed with schizoid or psychotic or a whole bunch of different things. So it's definitely true that there are a certain number of people that didn't get diagnosed because people didn't have that diagnosis in their heads. No question about it. It's definitely true that we changed the diagnostic criteria some 15 years ago, and it takes a while for people to catch up, and those diagnostic criteria are more inclusive. And so you got diagnostic substitution, so that you call somebody mentally retarded and now you're calling them autistic. All of these things have gone on, but the question is, does it explain the whole 1,200%? And most people who are raising these doubts did not go back and look at the literature to see if it explained the whole 1,200%. Irva Hertz-Picciotto and Laura Delwicci at the UC Davis Mind Institute actually went back and looked at the cases from California, 1990 to 2001, and did just that with the addition of birth records and census data and a variety of other materials, because administrative data is not always the greatest data to evaluate with. They could explain away maybe a third of it from age at diagnosis being younger. We're picking the cases up early, that artificially inflates the numbers, from including of milder cases, and from changes of diagnostic criteria. But they can't explain away the other 2/3 of it. And they made a statement that irritated a lot of people, which is that even though there's still a great deal of lack of clarity and a lot more to be learned, we stand by our statement that these increases need to be looked at as if they may have a real, true component. And I think from a public health point of view, again, if you put, because you have a belief system that this is genetic and therefore it can't possibly go up, therefore these numbers have to be an artifact, let's say you're wrong, and then the epidemic gets worse, and a lot of extra suffering, and if you want to get cold-hearted about it, expense is incurred for reasons that were preventable, there's no good justification for that. And and Jim Munson's had the report, pay now and pay later. I think we have to look now or look later too. Now, one of the things about if there's something going on, there's something in the environment. Well, there are many things in the environment and not just chemicals. There are also bugs and organisms and radiation, a lot of things. But the bottom line is that environment is not a constant. I have the blessing of going on November 21st to my aunt's 100th birthday. And she is still quite with it and actually guesses the punchlines of my jokes without prompting and with excellent timing still, and I'm very happy to be going to her birthday party. And one of the things I do with her, and that I did with my other parents before they passed away, and other relatives, was talk a lot about the past and take oral histories. And I love talking about what it was like to walk down the street when she was a little girl. and also with my father, who grew up in a different country. And I love getting these stories about how different it was. And I find it touching in a kind of disturbing way to hear some geneticists say, well, the environment is, it's all confusing, or really hasn't changed that much. I think that's a little bit, it's getting harder. I think in the last few years, it's been getting harder. The environment has really gotten some official recognition, whereas even 3 or 4 years ago, it was still, maybe people didn't want to think about it. This is a graph of the number of chemicals that have been produced new to nature, invented in labs somewhere, since from 1920 to 1980. That's a lot. If you look, I mean, it doesn't map directly onto those autism figures, but it maps onto a lot of things, population exposure, all kinds of things. But there was a nonprofit group, the Environmental Working Group, that looked at chemicals in the cord blood of newborn infants, and $10,000 a person, a baby. They looked for 454 some odd chemicals and found 287 in the cord blood, of which 180 are carcinogens, cause cancer, 217 are toxic to the nervous system and the brain, 208 cause birth defects or abnormal development in animal tests, and nearly 200 have been banned from the environment for years, at least in the US. These things are called persistent organic pollutants. They just don't, there is no a way for them to go. Epigenetics, I was telling you about epigenetics. Some really disturbing work is coming out in the epigenetic field. Why is it disturbing? It's turning out that even the low levels of chemicals, such as the levels that were found in this cord blood, are capable of having epigenetic impacts. One of the other things that I find really challenging about epigenetics is, I already told you that epigenetic impacts can last several generations. So how do you design a study where you're going to try and correlate environmental exposures with biological impacts when you don't know whether the exposure is the exposure to that person or their mother or their grandmother or their father or their grandfather or what? How do we even study that? And what I want to submit to you is that we were not thinking ahead when we got ourselves into this situation. And we need to be humbled by it. I put this slide in, the status of developmental toxicity testing for the top nearly 3,000 chemicals produced in the highest volume. We have some developmental toxicity testing on 20%, none on 80%. Only 20 to 30 have been tested for developmental neurotoxicity. We know that the developing nervous system is exquisitely vulnerable and sensitive, but there is no requirement for testing chemicals on the market for impact on that. And in fact, the test that we're using is not that good. It's not timed well to developmental vulnerable periods, and it doesn't go as long as behaviors emerge in the animal model system. I just told you that these little babies had 287 chemicals in their cord blood. We know now that chemicals in combination act differently than one at a time, but the testing is all done one at a time. If you would just test these in combinations of 3, it would take 85 billion tests, and we are never going to do those 85 billion tests. So in a way, we're never going to have the kind of precise scientific knowledge that we've been raised to believe that science is going to produce for us. We have created a chaotic situation. The situation is so chaotic that the United Nations, in their State of the Planet report from 2006, stated in the executive summary that ecosystem damage is so severe that we can no longer be confident that the planet Earth can support human life for more than 2 generations. Now, this report came out, I read about it all over the place in the UK Independent and the UK Observer, because I had those on my website. And the New York Times had a 3-paragraph news story buried somewhere. And I wrote a letter to the New York Times, which when I grew up in New York, it said on the top corner, and I think it still says this, all the news that's fit to print. And they give this 3 paragraphs. I'm like, what planet are you living on? You know, this is the most important story in human history, mammalian history, maybe planetary history. You're burying it. Oh, maybe you have another planet you're going to go to. Maybe you should tell us. They never printed my letter. But it was fun writing it. I knew they weren't going to print it. I have a good friend, Philip Shabakoff, and he and his wife Alice have a book called Poisoned Prophets about the impact of environment on children's development. Philip Shabakoff was an award-winning reporter at the New York Times who had to leave New York Times because they didn't like it that he was talking about global warming. So much for all the news that's fit to print. This is an article by Wendell Berry that came out in Harper's Magazine a year ago, and it was about the general state of affairs, and he made a comment that caught my eye. Our national faith, he was talking about the United States, has always been, there's always more. Our true religion is a sort of autistic industrialism. Now, there's a lot of people playing fast and loose with the word autism in the press. It's like a metaphor du jour. But I think there's something to it here. And it's like a repetitive and restricted behavior that we're engaging in, buying junk that we throw out, that won't biodegrade, throwing our garbage in the ocean and killing the fish and the atmosphere and so forth. And look at this, we're lining up cars. See that? And we're engaging in self-injurious behavior, and we can't recognize social clues. We can't recognize the screams of distress from the environment. Gee. So it's not just a religion, it's a problem. I think really that autism is a lot of what autism is about is a wake-up call to us, and I think some people will fight it kicking and screaming. I hope that they come around and open their hearts and realize that we really all have to deal with this together.